Hi, I'm Andy and this is question 7 on the AQA Mechanics 1 paper from June 2012. For more questions on this exam paper, click the eye in the top right corner. In question 7, a particle moves with constant acceleration of 0.1 I minus 0.2 j meters per second squared, and it's initially at the origin where it has velocity minus I plus 3 j meters per second. And it says the unit vectors I and j are directed east and north respectively. In part A, we need to find an expression for the position vector of the particle t seconds after it has left the origin. So we'll start by writing down what we know. We know that the initial velocity is minus I plus 3j meters per second. And we know the acceleration is 0.1 I minus 0.2 j meters per second squared. So to find a position vector, I would first of all find a displacement vector S using the formula S equals ut plus a half a t squared. Substituting in values for this, we would get minus I plus 3j multiplied by t plus a half of 0.1 I minus 0.2 j multiplied by t squared. And since the particle starts at the origin, the displacement vector, which just represents the displacement from your start point to your end point, is the same thing as your position vector, which is your displacement from the origin. So in this specific case, r is the same thing that we have here. So minus I plus 3j multiplied by t plus a half of 0.1 I minus 0.2 j t squared. Now in the exam, there's no real need to write down any of this information at the start. If you're confident with these kind of questions, you could just write the answer down straight away. In part B, we're asked to find the time it takes for the particle to reach the point where it is due east of the origin. So on my diagram with north, east, south and west, I is a unit vector to the east and j is a unit vector to the north. So if something is due east, it would be somewhere over here. And what that tells us is that the j component must be 0 and the I component must be positive. At the moment, our position vector is not in a very useful format because the i's and j's are mixed in together. So what I'm going to do is rewrite this position vector and separate out the I and j components. So in the first bracket, I will have the I component, and in another bracket, I will have the j component. So looking first at the I components, we've got minus I times t, so that would give me minus t in here. And then I've got half times 0.1 times t squared, so that's going to give me 0.05 t squared. For the j components, I've got 3t here, and I've got half times minus 0.2 t squared, which is minus 0.1 t squared. Now if the j component is going to equal 0, then that means that this bracket here has got to equal 0. So I can say that 3t minus 0.1 t squared has to equal 0. Factorising gives me t outside the brackets and 3 minus 0.1 t inside the bracket. And that gives me t equals 0, but that is when it's at the origin. And 3 minus 0.1 t equals 0. Which means 0.1 t equals 3, t equals 30 seconds, and this is the one where it is due east. In part C, we need to find the speed of the particle when it's travelling southeast. Now the key word in these kind of questions you're looking out for is travelling southeast. You need to make sure you can make the distinction between when a particle is in a position and when it is travelling in a direction. Okay, so for example in part B where it says it is due east, that is your clue that you need to use the position vector. In this question, the fact that it says it's travelling southeast means you need to be using the velocity vector. So to start this question, I need to use the formula v equals u plus a t. So the initial velocity is minus I plus 3j, and the acceleration is 0.1 I minus 0.2 j multiplied by t. So this time round, the particle is travelling southeast, and that means it's going to be going exactly 45 degrees between east and south. And remember, east is the I direction, south is the J direction. So to solve this problem, the I component must be equal to the negative J component. So before we can compare the I components and J components, we need to separate this out into the I and J components. So we would get V equals minus 1 plus 0.1t, that's the I component, plus 3 minus 0.2t J. So the I component, we'll leave that as it is, minus 1 plus 0.1t. But the J component, we're going to make that negative. So simplifying the right hand side, we're going to get minus 3 plus 0.2t. So subtracting 0.1t from both sides will give us 0.1t on the right hand side, and adding 3 to both sides will give us 2 on the left, which means that t equals 20 seconds. With that 20 seconds, we want to find the speed, so we substitute it back into the velocity expression. Because we're going to do Pythagoras with that, I would make sure that you substitute in the one where it's already separated out. So we get V equals minus 1 plus 0.1 times 20, and that's going to be the I component, plus 3 minus 0.2 times 20 for the J component. This gives me minus 1 plus 2, which gives me positive I. And here we've got 3 minus 4, which gives me negative J. So what this is really saying is that it's travelling at 1 metre per second to the right and 1 metre per second down. And so the speed, which we'll call the magnitude of V, is going to be the square root of 1 squared plus negative 1 squared, which is root 2, which is 1.41 metres per second to 3 significant figures.